Static shock. Girl, I could see your stinky sock. Put static walks. Now that's just what my teacher taught. Yeah. We gonna shock you like it's 3012 tonight. I wanna show you all the charges in the side. Yeah, did you know that everything has a charge? It's static rock, static shock. Negative and a positive. Charges attract and like charges repel one another. Yeah, did you know that? 'Cause
Do you ever notice that when you rub two objects together, they either repel or attract one another? Well, that's because one of the objects have a stronger hold of electrons, making it negatively charged. The other object, with the weaker hold of electrons, has a positive charge. There are three laws in electric charges. The first law is that like charges, such as positive and positive, repel. And the same goes for negative. Negative and negative charges repel. However, the second rule is that opposite charges, such as a negative and a positive, will attract one another. And the third law is neutral objects and charged objects are attracted to each other as well.
So I wonder what kind of charge these objects would get just by touching one another.
Well, why don't we experiment?
Marguerite, you're messing up your hair.
Don't worry, human hair has a weak hold of electrons, so when rubbing my hair against the balloon, I would make the balloon negatively charged.
And making your hair positively charged since it just lost its electrons to the balloon. But what you just did, wasn't that charging by friction?
Yes, you're right, but when charging by contact, you need an object that is neutral and an object that is charged. Like, for example, paper. Thank you, Shania. Now, please look. Wow, do you notice?
Wow, so amazing.
Look! Now that I placed contact with a neutral charged object and a charged object, they are attracted to each other, and since it was charged by contact, the paper gets the same type of charge that is on the object that charges it, making the balloon and paper negatively charged.
Did you know that electricity plays a role in the way your heart beats? Muscle cells in the heart are contracted by electricity going through the heart. Electrocardiogram machines used in hospitals measure the electricity going through someone's heart. When the person is healthy, it usually shows a line moving across the screen with regular spikes as the heart beats. Well, now you know.
Hey, what are you guys talking about?
You were talking about static electricity.
Diana, did you know that a charged and neutral object attract each other?
Once it's attracted to each other, doesn't the neutral object get the same charge as the charged object?
Yes, they attract.
But don't like charges repel?
Well, that's called charging by induction. I can try and explain why. You see, the balloon, that had a negative charge, and when it comes in contact with the paper, which has a neutral charge, they both attract each other. Now that they attract each other, when it's charging by contact, the paper becomes negatively charged since the neutral charged object gets the exact same charge by the object that was charged. Now that they have like charges, they start to repel, which moves the electrons farther away, which creates a positive side on the paper, which makes the negatively charged balloon and the paper attract since opposite charges attract.
Oh!
Ha ha ha!
Have you ever wanted or felt the need to detect the presence of electric charges?
Yeah.
Well, look no further. We have the perfect thing for you.
Oh my god, oh my god, oh my god. Mine.
It's called, drum roll please, a Metal Leaf Electroscope 3000.
Wow.
I know what you are all thinking. Oh my gosh, I need that. But I know most of you are also wondering, how does it work? Well, the Metal Leaf Electroscope 3000 consists of a sphere that is connected to a rod, which has metal leaves attached to it. The sphere, rod, and leaves are all made of metal, which allows electrons to move freely. The rod and the leaves are enclosed in a glass container to shield the leaves from air currents. The leaves of a metal leaf electroscope spread apart when a charge is near the sphere, or when the electroscope has a charge.
Can you show us how it works?
Sure, just take a look. When you have a charged object like this pen, you bring it close to the sphere on top of the Electroscope 3000, and the electric force between the two objects is transmitted by an electric field. This electric field allows the electrons to flow from the glass rod to the sphere, the metal rod then to the leaves, which causes the leaves to repel each other.
How much does it cost?
Well, young lady, if our viewers call to 1-800, we want your money, in the next 30 seconds, they will get our once-in-a-lifetime offer.
Oh my gosh. How much does it cost?
You can own the Metal Leaf Electroscope 3000 for only 25 payments of $19.99.
$19.99?
Yes, only 25 payments of $19.99. But call quick before our limited time offer ends.
Caution. May take your electrons.
Welcome back. If you missed a special offer from that commercial, don't you worry, because we can show you how to make a metal leaf electroscope with things you can find around the house you need. What you need is a jar, plastic cover, tinfoil, copper wire, scissors, actually tape, and a pair of scissors. The first step is that you take your jar and you cut a hole into the middle of the cover for the opening of the copper wire. Then you take your copper wire and you make a loop on the top and a bended L shape at the bottom, so you can get your foil and put it in like this. Make sure that your foil is thin and it is rectangular shaped and there is an opening so the copper wire can go through. Finally, you put it in through the plastic lid like this. And then you put it back and you screw it or put it back onto the glass jar like so.
Don't you just hate when you're doing your laundry and then when you take it out of the dryer, they're all stuck together?
You can call that static electricity.
What is that?
Well, when your clothes are being rubbed together in the dryer, they build up on static electricity. Static electricity refers to an electric charge that tends to stay on an object's surface rather than flowing away quickly.
Oh.
Has this ever happened to you? So Shania, remember a time where I was never cool? I don't remember either. Oh my gosh, look at her butt! Oh my gosh. You know what that girl needs? She needs a static be gone. The what? A static be gone. What does it do? Well, if your clothes keep sticking together like yours, then you need to take the static be gone and spray it onto your clothes so they will no longer stick. Guaranteed.
Oh my gosh, where can I get it?
Just call our toll-free number 1-800-STATIC-BE-GONE and it will be shipped to your door in 4 to 6 business weeks.
How much is it?
Call in the next 330 seconds and you will get Static Be Gone for the low price of $29.99.
Disclaimer. No feelings were hurt in the making of this video. Ammeter measures current. Current can be calculated by Current equals voltage divided by resistance. Current equals power divided by voltage. Current equals coulomb divided by second. Current is measured in amperes, also known as amps. Voltmeter measures voltage. Potential difference voltage can be calculated by voltage equals current times resistance, voltage equals energy times coulomb of charge, voltage equals power divided by current. Potential difference voltage is measured in volts. Resistance can be calculated by resistance equals voltage divided by current. Resistance is measured in ohms. Energy can be calculated by energy equals power times time. Energy equals voltage times coulomb. Energy can be measured in joules. Power can be calculated by power equals energy divided by time. Power equals current times voltage. Power is measured in watts.
Did you know that electric eels can produce strong electric currents of around 500 volts for both self-defense and hunting? Well, now you know.
How am I supposed to complete this assignment on circuits? I don't even know what a circuit is.
I could try to help. An electric circuit is a closed path where electrons that are powered by an energy source that can flow. There is a closed and open circuit.
If it's an open circuit, where do the electrons flow?
Well, an open circuit has a gap, so technically the flow of electrons have nowhere to go, and thus stop working. Unless you have a switch, you will be able to resume or stop the flow of electrons, like when switching the light on and off.
Oh my gosh, thanks so much. I think I have a better insight on circuits.
Hey Diana, what are you doing?
Hey Marguerite, well, I wanted to construct myself two types of circuits, a series and a parallel on PAHET, but I just don't know the purpose of these tools, voltmeter, ammeter, and a resistor.
Oh, well, an ammeter, measured in amps, measures the electric current. Electric current is how fast the electrons in the circuit are moving. In order to measure current, you must use an ammeter, being in series in the circuit. If you notice in this series circuit, the current is the same across all the loads, but in this parallel circuit, the current is split between the loads to equal the total current.
Oh, well then what does the voltmeter measure?
The voltmeter, measured in volts, measures voltage. Voltage is potential difference. It is the difference between the electric potential energy per unit of charge at 2 points in a circuit. When wanting to measure voltage, you must use a voltmeter connected in parallel between the terminals of a load. Notice how in the series circuit, the voltage is split between the loads, while in a parallel circuit, it is the same across all the loads? Now, a resistor is a property of a substance that slows down current and converts electric energy to other forms of energy. In a series circuit, see how the resistance increases while in a parallel circuit it decreases. That's because in a parallel circuit, the electrons have more pathways to follow in to avoid collision in traffic.
Now I will be able to understand what I'm building and what tools is needed to measure. Things such as current and voltage. Gee, thanks.
No problem.
I wonder why my calculator doesn't work when it's in the dark.
That's because your calculator is solar powered. It uses solar energy, which is produced when light from the sun's rays are transformed into electrical energy by solar panels, like the one that's on the top of your calculator. It's a renewable source of energy.
Are there other renewable energy sources out there?
Of course. Ever see those giant wind turbines out on the field? Well, those are windmills, and it uses wind energy to produce electricity. Wind energy is generated when wind power is transformed into electrical energy.
I hear of this hydroelectricity. Is that a renewable source of energy?
You've been to Niagara Falls, right? Well, Niagara Falls produces electricity using hydroelectricity. Hydroelectricity is created when water is moving. When water runs through a man-made dam, it pushes a turbine which creates electricity.
Wow, such awesome ways to produce electricity. Why aren't they very popular?
It's too bad, they're too expensive.
Not for me. Ha ha ha.
All of the lights baby. Extra bright, I want y'all to see this. Turn up